Okay, now from the previous problem, we want to calculate the moment of inertia of this unequal T section, and of course we have discovered, or we have calculated that the neutral axis is at a distance of 62.5 from the top of the rectangle E1. But we also know that the centroid of that top rectangle is 25 millimeters, or 25 whatever units, 25 inches or 25 millimeters from the top. So that means that this distance here, that means from the centroid of the top rectangle to the neutral axis, this will be equal to 62.5 minus 25, okay, or 37.5. Alright, so if we use the general formula for moment of inertia, I1, which is the moment of inertia of this top rectangle, equals to B1 H1 cube divided by 12 plus A1 P square, and this is actually P, which is the distance of the center of the section to the neutral axis or the axis of rotation. Okay, so if we input the values there, because B1 here is equal to 250, and then we have H1 here, which is equal to 50. So B1 250 multiplied by 50 cube divided by 12 plus A1 previously we have calculated as 12,500 times P square, which is 37.5 square. Okay, let's get up my calculator there. So that's 250 times 50 cube divided by 12, right? So we add this 12,500 times 37.5 square. So this is what we get, 20,182,291.7. Okay, so we can just use if we put 2.018, so that's 1, 2, 3, 4, 5, 6, 7 zeros after that, so that's 2.018 times 10 to the power of 7. Right, so that's I1. Now for I2, we have the bottom rectangle there, and the bottom rectangle is got a H2 of 150, and it's got a B2 of 50. Okay, so then if we draw the neutral axis, is something like this. So the neutral axis here, and this neutral axis distance here is 12.5 here. This is because from the top to the neutral axis 62.5, and then this H1 here is 50, so that means here must be 12.5. Okay, so it's going into the bottom rectangle as much as 12.5. We also know that bottom here, the centroid, bottom rectangle for the centroid, the centroid for the bottom rectangle is half of 150, means it's 75. Yeah, so that means that the distance between this centroid to the neutral axis will be equal to 75 minus 12.5. So this is 62.5. Okay, so now we can use the same formula as this one here. So that will be I2 equals to B2 H2 cube over 12 plus A2 P square. Let's say P2 square. Okay, and this one here P1, it should be P1 here. Okay, so this value here that we got last time is I1. So now we're calculating, of course, I2. So if we input the values there, B2 is 50 and H2 is 150. So we cube this, divided by 12, plus A2. Last time we found A2 to be 7,500. Okay, times P2 square. So we found that P2 square is 62.5 square. Alright, so just take up my calculator. So that's 50 times 150 cube divided by 12, and then we add 7,500 times 62.5 square, and get value of 43,359,375. So this is equal to 43.359 times 10 to the power 7. Okay, so this is I2. So we add I1 and I2 there in order to get I, or the moment of inertia for the whole section. Yeah, so I is equal to I1 plus I2. So that's equal to 2.018 plus 43.359 times 10 to the power 7. This is 2.018 plus 43.359, got 45.377. I just round it up to 45.4 times 10 to the power 7. Okay, so that is the answer.